Hi, welcome back to SQL Server 2016 Administration. This is Volume 3 of the courses. And in this section, we'll look at advanced security features. In this section, we'll start by covering transparent data encryption, or TDE. We'll look at what it is and how does it actually work to secure your system as well as something. Let's start this slide again. In this section, we'll start looking at TDE, or transparent data encryption. We'll talk about what TDE actually is, how it works, and how you can set it up. We'll then move to Always Encrypted, which is a new encryption feature in SQL Server 2016. We'll look at the architecture as well as how to administer this and set this up. Next, we'll go to column level encryption, which is advanced encryption that has been around in SQL Server for a while, but we'll look at the specifics of this. We'll next move to row level security, which is a new feature in SQL Server 2016 that allows us to administer security on a row by row basis. And finally, we'll finish off with dynamic data masking. Not really a security feature, but a programming feature. Microsoft lists it in the security section, so we'll cover what this is and how it affects your application. This is the video on transparent data encryption, the first part of the advanced security features section. In this video, we want to cover what the description of transparent data encryption is and the restrictions and requirements. Then we'll look at how we both enable TDE and remove it. Transparent data encryption was introduced in SQL Server 2008, but it's still widely used, and it's actually the default for Azure SQL Database at this point in time. We usually do refer to this as TDE, so if you see me or hear me refer to this as TDE, that's what I mean. Keep in mind, this is actually a database level encryption feature, so it encrypts an entire database at once, and it doesn't require any application changes, which is why it's called transparent, because there are no code changes. No application is aware that it's been actually implemented. The way transparent data encryption is designed is it encrypts the data at rest. The data at rest consists of these particular objects: the MDF or NDF files that store your data and indexes, the transaction log files that track all the activity, TempDB files, because our queries often spill into TempDB, and that includes both the data and log files of TempDB, and then all of our backup files. Each of these types of files is actually encrypted on disk. Now, because this is transparent, all client queries look the same. When you connect to a TDE-enabled database, it looks like any other database you connect to. Your access is the same as it would be without transparent data encryption. From the client side, everything's the same. No code changes are actually required. The thing to keep in mind is that data that's stored in memory or read into memory is not encrypted, and data on the wire is unencrypted as well. So this is just a disk level encryption feature. The main requirement here is that we have Enterprise Edition. This does not work on other editions. So it is an enterprise level feature that is often used to satisfy an auditing requirements. So be aware you need Enterprise Edition. In this video, we'll use Developer Edition, which contains all the features of Enterprise. Evaluation Edition also contains features of Enterprise, but both Developer and Evaluation are not suitable for production deployment. In order to set up TDE, this is the process that we need to follow. We'll create a master key in a database, in the master database, in fact, and this is kind of a base level encryption feature inside of SQL Server, which we'll talk more about in another video. We then create a certificate in the master database, which will be protected by the master key, but we don't have to do anything there. And this certificate is actually what will protect our encryption. We do need to back up the certificate. There is no recourse if you call Microsoft support and you lost the certificate, so please back this up immediately. We then create a database encryption key in the database, and this is the key that encrypts the data and is protected by that certificate we created in the second step. And lastly, we simply turn encryption on. So let's see how this actually works. Here I am in Management Studio, my demo system, and you'll see I've got a number of databases here. I actually want to create a new database here called TDE Primer. And once we do that, we'll see that it's been added to this system here if I refresh it. And let's actually add a table in this database for the purposes of understanding encryption. And then we'll put some data in it. And when I do this, you can see that I've put my name and a repeating pattern here as part of the data. And I've got just added a number of rows to kind of fill it out. Let's now detach this database. Now at this point, the database is no longer a part of the SQL Server and the files are separate, so let's look at the files. Here I am on my local SQL Server system where the database is running, and I have XVI32, which is a hex editor. What I want to do is I want to actually open up my TDE Primer MDF file. This is the MDF file that contains my data. There's the log file, and if we open this up, first thing you'll notice is there's a little bit of header information, so the name of the database is actually listed here. If I scroll down, I see a number of zeros. And if I do a quick search for my name, here's my row of data. So there's my name, and there's all those A's. Here's my name, and there's all those B's and C's and etc. So this is actually the data on disk. I'm not using SQL Server here. I'm using a hex editor. If these were national ID numbers, social security numbers, credit card numbers, these would all be visible without SQL Server and without any protection. So that's what we're trying to avoid, is allowing a laptop, a backup disk, or anything to fall into criminal hands where they could actually read this information. So TDE will protect against this. Let's close this and go back to Management Studio. Back in Management Studio, we're going to reattach our database, which is fairly simple. We'll make sure that our table still exists, and it does. And again, there's that data. Now let's start the encryption setup. Now this is documented in Books Online, and I've got it listed here. But here's essentially what we do. We will create a master key here, and I actually want to do this in a master database. This master key is the basis of all encryption in SQL Server for the master database. In this case, it's protecting a certificate, so we'll create that by ourselves. Now by default, this is a self-signed certificate that expires in 1 year. We'll talk about certificates a little more in detail in another volume, but for now, this is what I use to protect my database. And then what I'll do is I'll create in my TD Primer database a database encryption key. Now you'll notice here that I get a warning if I haven't backed up the certificate, not this database encryption key, but the certificate itself. I get this warning. Please treat this seriously and back it up immediately. So let's do that. When I back up a certificate, I actually have two parts. I have a certificate and a private key file that get created, and of course I do want a very strong password. You will want to keep track of this password. If I ever need to restore my TD database on a different instance of SQL Server, I will need to first restore the certificate with this password. If I look at the encryption status of my system right now, what I'll find is that my TD Primer is not encrypted, but it has an encryption state of 1, which means that that key has been created. By default, that key is a 128-bit key. I could have changed it to 256, but I didn't do that on purpose because I wanted to show you something. You'll notice that nothing else is encrypted at this point in time, and there's no state. To turn on TDE, we'll do this simple alter database, set encryption on, and then let's check the status again. Now this does spawn a thread in the background and encrypts page by page. It's a very small database, so it occurs quickly. You'll notice at this point in time my encryption state is 3, and I've actually encrypted. If this was a larger database, this would be a 2 while the database is being encrypted, and I would have a % complete here that I could monitor. You'll also notice that TempDB is now encrypted. This is because any information that I may spill into TempDB from queries, work tables, that kind of thing, I want encrypted as well, so I'm trying to avoid any data leakage if somebody were to get a copy of my TempDB files. You'll notice the default here is 256 encryption for AES algorithm, and I have a little less encryption here. I can't increase this any further as of right now, but perhaps in the future this will change. Let's detach my database again, and we'll go back to the hex editor and take a look. Back in my hex editor, let's open up that file again. Find the TempDB database, or the TD Primer database rather. Once I open that up, this looks the same. I still see a header here. But you'll notice as I scroll down, I see a lot more encrypted information. If I were to perform that search again, the data is not found because it's all encrypted at this point in time. There are a few caveats with transparent data encryption. First, this is encryption that requires CPU resources. All encryption and decryption will be processed in a mathematical way, so it requires additional CPU or GPU resources. However, on modern systems, this is usually fairly minimal. In general, it's less than 5% on most client systems, but you certainly would want to test this. The other thing is that all connections and queries against SQL Server are the same as they would be from any other system, so SQL injection or other attacks are still issues. TDE does not prevent these. This is really only preventing attacks on physical files, so any loss of the physical file or disks. One important thing is you have to track the passwords used for the certificates. As I've mentioned, if you restore to a different instance or you have a disaster recovery situation, you need the password in order to restore that certificate. And the last thing is, on large databases, when you enable this, it takes some time to enable TDE. You may have objects in TempDB or the log file that query this particular database where you've enabled TDE, and while the encryption occurs, we're not going back and encrypting data in log files or TempDB that is unencrypted. So until you reboot or have a log backup, you're not assured that you have complete encryption. Things to keep in mind. In our next video, we will cover Always Encrypted.